All right, so I'm recording and I'm sharing the screen. All right, so we are going to get started. All right, so pretty much everything is on Brightspace. So we're going to start there. Um, so so on the agenda today, we're going to go over the syllabus, kind of motivate the course. Um, I'm going to tell you where everything is, all the links and everything like that. And then we'll get into some of the material, right? So it's a cybersecurity course, and specifically within that, it is cryptography, which I think should be pretty fun. If you like puzzles and things like that, that's kind of the way it's going to feel, I think. All right, so hopefully. So there will be, we'll look at algorithms in cryptography, all the major ones, and you'll be using cryptography for different things and understanding some of the concepts. All right, so let's go ahead and take a look at Brightspace. So this is the fall 2025 ITS 350 uh, Brightspace. Course, as I said, is fundamentals of cryptography. So all the materials usually live here in the table of contents. So this is where I'm going to put everything. I've loaded all the materials already, but I may change or add new materials as we go through the semester. But pretty much everything is cryptography. And so we'll take a look at that. So this first module is just the exit surveys at the end of the semester, the term project. So we'll talk about that later in the semester. We'll start here in this admin module. So this is going to be the syllabus. So that's the current syllabus. So I'm going to take a look at that. All right. So this is, as I said, ITS 350, Fundamentals of Cryptography. I'm Professor Calix. This is my contact information, email. I'm in Anderson 238. This class meets, Tuesdays and Thursdays, 4 to 6. Office hours are going to be Monday and Tuesday from 2 to 4 p.m. Okay. So, or otherwise, that you can find me in my office, then otherwise you have to make an appointment via email. The prereq for this course is ITS 250, and I assume all of you took that course, right? It's the intro cybersecurity course, bunch of topics. I'm sure you covered a few things related to cryptography. Obviously, this course goes, in depth into a lot of them. We'll spend all semester on it. The textbook it's not required. I mean, there's several textbooks out there. I think, a lot of those textbooks are not something that you would enjoy reading. But this one, computer security, you're familiar with it. You probably have it for other courses. So it's got a few of the labs that we will do in the course tie into this book. So if you have it, it's great. You can read the cryptography chapters, and that might help you. I'll provide all the materials, all the links and everything. Okay. Yeah, but I'll provide the notes. Usually I'll have a GitHub where all the code lives. And I might have, I use the READMEs in GitHub, or the materials will be here on Brightspace, like PowerPoint slides or notes. Take notes, I would say also. So the course description, we can go over that. So this course covers the implementation of systems assurance with computing systems and cryptography. Okay, the topics include confidentiality, integrity, authentication, non-repudiation, all focusing on encryption techniques. So you'll see how you can do authentication with encryption, you can do confidentiality, integrity, all those things are the pillars, like the thing you're trying to protect. And then you use cryptography essentially to defend. So basically, this is, although this is a cybersecurity course, most everything that we cover is for defense, right? So to achieve one of the pillars. And today I'll motivate some of these, and these are probably things that you already studied in 250. like what is confidentiality, what is integrity, but we will go over that again today, as that's going to be very fundamental. So actually, a lot of the time I'll say, talk about RSA from the point of view of authentication, right? So how does that work? Something like that. All right. So yeah, so there's a lot of labs. So usually there's going to be like a lab assignment every week, right? So it's a lecture and lab course. So lectures on Tuesday and then lab on Thursday. And so we'll start getting into that. Um, Here's some of the learning objectives. So, you want to know what you're protecting, the pillars, the assets. We're going to have some terminology like what is symmetric and asymmetric encryption. So we're going to look at that. What are hash functions? What is the RSA algorithm, right? So we'll take a look at that. What is access control? Uh, there's going to be some things related to denial of service attacks and other things like that, but from the point of view of cryptography, right? So how you can actually defend for denial of service attacks using cryptography, for instance. So that's essentially the theme. And then I will start the course with this term SSL and TLS, and I will end the course with this term, right? So I will say at the very beginning of the semester, here's SSL, this is what it means, but I really can't explain how it works right now. And because you're not going to fully understand it until we've spent, 10 weeks covering a whole bunch of topics. And then at the end of 10 weeks, I will say, okay, now you can understand what SSL is. All right, does that make sense? So this builds on a lot of ideas. So this course is like that. Every week builds on topics from previous weeks. And it's very modular, etc. So you want to understand cryptography, how cryptography can facilitate confidentiality, integrity, and what is non-repudiation. So we'll look at that, authentication, and so on. All right. I do cover towards the end of the semester even a little bit of Bitcoin and the blockchain, just to kind of because it ties in. How does that work, and how does it tie into some of the what are called the cryptographic primitives, in cryptography. All right, so we'll learn all these building blocks. We'll learn that there's this basic operation called the XOR, which you're probably familiar with, and you're going to see how that is used quite a lot. Okay. Right, so grading and assessment. So exams, that's 30% of your grade. You'll have 3 exams, one on week 6, one on week 12, and one during finals week. Each one of those is going to be 10% of your grade. There is a quizzes, 10% of your grade is quizzes, team project, professionalism in the classroom. Usually I do pop quizzes, right? So I'll do a few of those about the topics that we're covering. And, as long as you're in class and try, you should be okay. The term project, this is a 300 level class, so the project is only worth about 10% of your grade. And then as you can see, the majority of the points come from homework assignment. If you do the homeworks, you'll do really well. If you don't do the homework assignments, you could fail the course. Okay, so definitely pay attention to that. Some students think if I just take the exams, I'll do fine. They don't actually see that the exams are not worth that much, right? So really the homework assignments or lab assignments are really important. Any questions so far? Nope. Right. Yeah, some of the course policies, please read the syllabus. And I'll be recording the session so that you guys have something to look at, but you're still required to come to class, right? I'll post these. My main thing is with homework assignments, you should submit all homework assignments on time via Brightspace. I don't accept homeworks that are submitted via email. Okay, so that's like my one rule because it gets impossible to deal with. All right. So definitely please, do your homework assignments on time, submit them in Brightspace, please. All right. I don't really care much about like formatting of homework assignments as long as it's correct, right? So, and knowing that your homework assignment is correct depends on you understanding the topic that you're doing, right? So pay attention to what you're doing because you'll know when you've done it correctly if you understand the topic. This is the emergency procedures guide, so please go ahead and read through that. And then I have some of the topics here. This is usually how I follow or the schedule. So we'll start with some basic ideas, cryptographic tools, block ciphers. So that's usually where we start, symmetric encryption. Then we will look at integrity and hash functions. So we'll take a look at that, how those things work, those algorithms. Uh, so then, symmetric encryption in more detail, some of the more specific algorithms, and then public key cryptography. All right. So you need all these different techniques, I should say, to build a proper encryption pipeline. We'll take a look at something called PKI and public key infrastructure and signatures. We'll take a look at RSA, as an encryption technique. There's something called elliptic curves, so we'll take a look at that as well. And a lot of these things are based on math, but it's like it's not as hard as you might imagine, right? So it's pretty straightforward, and because everything is gonna be an algorithm in Python or something like that, it'll be something that you can see how it works. Yeah, so we'll take a look at data encryption standard. We'll take a look at malicious software, computer viruses, and how cryptography is actually used for that, for defense. So we'll take a look at those topics. Yeah, and like I said, so those are some of the ideas. You'll see how we progress through the semester. All right, so that's the end of the syllabus. Are there any questions? Yeah, please go ahead. To come to class, I think you need to come to class. Yeah, I believe so. That's the department policy. All right. Usually, and what I do is I'll demo things and go over try to help you guys to solve some of the problems. I may not be able to solve all of them, so you can solve them on your own. All right. So yeah, so that's the syllabus. Let's go back. All right. Now let's go to the table of contents. So we're done with the syllabus. Resources. Yeah, so here, one thing you'll need for this course is the seed VM, right? So probably that's what I recommend that you use. How many of you have used the seed VM already? Show of hands. Really? Seed VM? Okay. Do you know what I'm talking about? Like yeah, VirtualBox. You've used VirtualBox, right? Okay. And Linux. Maybe you use Kali Linux, I guess, in 250. Is that what you're using? All right, Kali Linux. Okay. So CVM is similar to Kali Linux. It's just another Linux version. So you will have to set that up. All right. So yeah, we use Linux essentially for everything, right? So for some of the labs, you don't need the CVM, but for some of them, it's helpful because it's got some of the software installed already. So my suggestion is then that. All right, so these are some of the instructions. So the first thing, you can follow these instructions. You'll need to uh, download VirtualBox. That's going to be your virtualization environment. Okay. And follow these instructions. You will need to download a file from the Seed Labs website. So that should be here. This is the Seed Labs. So you can see here they have a lab setup, and you've got, Ubuntu 2004 VM. So you can download the file, follow those instructions that I provided, and essentially you boot up your virtual machine. You guys understand? Yeah. So I guess that's your first homework assignment, right? So try to do that by Thursday. Okay, and if you're having problems on Thursday, let me know, but it should be 80% of you should be able to. And there's always a few issues that happen, a few errors. So I think I do have like fact that I've used in the past, common errors setting up your VM. So I have here some useful links. If errors, install seed VM, so you can take a look at those if you're having some issues. Okay. Some of the more common questions that I've had in the past you can find there. Questions, but essentially VirtualBox, which is free. You don't need a license or anything like that. Go to the Seed Labs, which is that website I just showed. Download the file, follow the instructions, and boot up the virtual machine. Today, towards the end of the class, possibly I'll boot it up just so that you can see what it looks like. But we just need a Linux environment, okay, for some of the assignments. Got it? Any questions? Yeah, please go ahead. Yes. Yeah. If you have that one, you can just use it. Did you do if hmm? Oh yeah, you can use it. If you that's what I thought some of you had used the CVM. I was going to say, okay, just use that old one. It's fine. All right, but yeah, you just need something like if you want to follow what I'm doing, I'll be using Linux, so and I'll be using the CVM. All right. So any questions about that? So those are some of the resources. So one of the key things to start with is setting up the virtual machine. So like I said, you can find the files here. And yes, go ahead, please. Which one? Which one, sorry?
On the website.
I think either one of those, they're just like different places where they're storing it. Yeah. So you should be able to use any one of those. Here's also, it has a link how to build a seed VM from scratch. So what I suggest is probably read the document first before you start actually following the steps, just so that you don't miss anything. But in the past, it is pretty straightforward. All right. So yeah, so these are some of the resources. So the seed VM is a big one. You can find the videos here. This should be the GitHub. So a lot of the code that I'll be doing is here. So you can find it and you can just get it from there. Okay. So you don't have to like really quickly type everything that I'm doing. Everything that I'll be doing is already posted. And just make sure you understand it, that you can adapt it, etc. Okay. And like I said, I have some notes. I'll be, I move around between the different things. All right, so that's the module for resources that you might need in this course. So yeah, definitely today I don't plan to do like any lab demos, but I do plan to do that on Thursday, right? So you want to try to have that set up by Thursday, okay, so that you don't fall behind. Any questions about that? Yes, please.
You teach the labs too.
I teach the labs too. Yeah, so I'll be here on Thursday as well. Any other question? Right. And there's always a hiccup here and there with the CVM, but as I said, you should be usually the main problem is if somebody has a Mac, that's a common thing. It's a different installation for that. So hopefully if you have Windows, it's like the most straightforward approach to set things up. If you have a Mac, if you have an M1 chip, all that, it starts compounding and with problems. But I believe there, if you read through the website, it even says here's for M1. So just make sure you have the right version. The current version of Linux is 2004. That's the one that whenever they update to another one, we'll to that one. To that. Okay. All right. So yeah, so resources probably one of the challenging parts when we start is getting that set up. So we'll see how that goes, but try to have it by Thursday. All right. And then yeah, so those are all the resources, I think. Now we can move on. And then once we move to this module here, secret key encryption, essentially we are starting the semester with the topics that we're covering. So gonna click on this. So I'm gonna just go over what's in here first, and then we can start talking about the concepts. So usually what I do is every week is a module. So like this is 1 week, this is 2 weeks, but sometimes some topics will last more than 1 week, right? And so this is really just the starting point. We start with secret key encryption, the XOR operation, etc. I do have a set of slides for this. I'll cover those today. I also have in here the materials for the first lab. So on Monday, on Thursday, we will start doing our first lab, which will involve some of these files. Okay, so you can see we have an ASCII table. This is, we have an image, a picture. We'll be encrypting that image. So you can see how we're going to just start encrypting things like images, text, etc., and just trying to understand the different algorithms and how they work. So this, just to motivate, this is the first lab, crypto encryption. So usually these labs are things that you should read, and we don't necessarily answer every question in these. I will always create like a separate Word document of the problems that you have to solve. So what these are is basically they have a lot of information to help you out. And so what I suggest is read through them. Okay. They provide a lot of details, and then we will selectively do some of these problems. Okay, you can see that here. So we'll explore concepts like, ECB versus CBC, modes of operation in symmetric encryption, or how to encrypt an image, padding, what is padding in the context of encryption, and so on, right? So we explore a lot of topics, but you're not responsible for answering every question in these. These are just more like for you to read and to help you out. And then here, I should have a Word document. This one, homework 1, secret key. Which has some of the so here is where I'm saying these are the actual problems you have to solve. This is the actual homework. And I may change this, from semester to semester. Does that make sense, guys? The difference? Okay, so this Word document is your actual homework assignment. And I'll repeat it obviously when we're talking about the assignment, but I just want to give you that information. Okay, so yeah, so we'll start that probably not today, but this is this week's homework assignment, and then usually I'll create the assignment link. This is from last year. I just copied it, and I might list out like the problems as well. Here, kind of duplicate the same thing as in the Word document. Any questions on that? As far as homework, what should you submit? I would recommend just download the Word document, right? And then start answering the questions, right? For some of them, you just have to provide some evidence that you did, that you solved the problem. So that means screenshots, etc., that show enough evidence, convincing evidence that you solved it and you understand what was required. Got it? Yeah. So that's the idea. And then you can just submit that Word document or PDF. Please, you need to submit a report. Don't submit like like just the images or something like that. Put everything in one single report, which should be a Word document or PDF. All right. Yeah, so that's kind of the first module. And then after that, in the coming weeks, we'll go over other ideas. Like you can see the Python substitution cipher. So Python, right? So how many of you have used Python? Half of you, or most of you. So Python is an easy language. You'll pick it up if you haven't used it. I don't ask you to write code from scratch exactly. What I do is I provide the code for you, and you may need to understand how to use it, modify it, certainly. But the goal is, it's not a coding class, right? So I'm not really grading coding. I'm grading that you understand the algorithms and how they work. Okay. So I do this Python substitution cipher because it helps us to just get reacquainted with, a little bit of the coding aspect, and then, we'll go from there. So this is a substitution cipher is like a old or classic encryption technique, not a modern encryption technique. So after this one, we'll cover XOR. XOR is one of the underlying operations in cryptography. We'll talk about it and why we use it. And you already know what XOR is. So it's the truth tables, right? So you all know the XOR truth table, and that's exactly what we're doing because computers are what? Zeros and ones, right? So bits. And so we'll be doing that operation for encrypting, but there's an algorithm, right? So that's just the underlying operation, like a multiplication or an addition, but we use that then within an algorithm, and you'll see that. Hash functions, we'll explore those. Symmetric encryption and the data encryption standard. Then we'll look at RSA, some additional libraries, certificate authorities, and digital signatures. The crypto practical exam. So there will be what I call a scavenger hunt. I will encrypt several secrets, and you have to understand cryptography to be able to find them. And that's done during a lab session. So it's a practical exam. But that's later in the semester. We'll talk about public key cryptography, big num, cryptography from the point of view of malware, denial of service attack, and I think and I wrap it up with like blockchain and cryptocurrency, just some of the concepts, not obviously from the point of view of the economics. So you're not going to learn here how to invest in crypto. I don't recommend that. Instead, we're just going to look at how it might work, some of the ideas and how some of the things. It's essentially hashing functions, right? So hashing, which is one of the primitives that we will explore, is one important thing used in blockchain. Elliptic curves actually are also another of the algorithms that are used there, right? So we will look at that at the end of the semester. And that should get, right? So that's essentially it. Now, there is, of course, this whole thing about quantum ready cryptography, but a lot of those algorithms, I should say, so they're like, oh yeah, we got this algorithm that is quantum ready, and then 6 months later, they find that it's not, that it's got a vulnerability, or some people were able to break it. Do you see what I'm saying? So, and what that means is, currently there's a big effort going on. People are concerned that once a quantum computer is invented, right, and it's functional, that a quantum computer will be able to break all of cryptography. And so through the semester, we'll discuss these ideas, and hopefully by the end of the semester, you'll understand, okay, you will learn how we can break RSA, for instance, right? So we'll look at RSA and we'll look at some of the security of it, and then what is the way that people try to break RSA. And as it turns out right now, it would take a very long time for somebody to break something like RSA with conventional computers. But there's already an algorithm called Shor's algorithm that runs on right now, theoretically, it runs on a quantum computer. But once a quantum computer exists, it should be able to break RSA. Now, RSA and those algorithms are used every day, right? So today you looked at your email, you maybe went on Amazon to buy some things, you got in on Brightspace, you watched your TV shows at home, all of that is using everything that we discuss in the class, right? And so if somebody breaks those algorithms, there's no more online banking, no more anything, right? And so it's a big problem, a big worry. And so, but most of the algorithms right now, most of the cryptography, I mean, I'm sure there's some recommended things, but it's just very early stage. Okay. So we'll see. We'll take that topic more as a researchy topic, a special topic, and we can discuss if we hear anything in the news about it, things like that. Does that make sense? Yeah. But obviously, to get to something like that, you probably should understand what is currently being used, right? Which all these things are currently in use. Okay. It's not like, this is old things or historical things. This is actually the technology underlying your TLS, right? Etc. Does that make sense, guys? Any questions? Any comments? Nope. All right. Yeah, so let's get started then. So I should do. So this was kind of like the introduction, the motivation to the class, right? So I'm gonna just save that as a separate video.